This video contains the corrections for the midterm homework. Question 1. A student carried out the preparation of benzoic acid by oxidizing 1.8 centimeters cubed of phenyl methanol. Now, I know I'm probably going to need that, so I'll note down what that is in relation to. The oxidation was carried out under basic conditions and a saturated solution of potassium permanganate in a conical flask. After heating the solution for 20 minutes, it was cooled. It was then acidified. Sodium sulfite was added. So they're giving you all of the steps here, is what I'm seeing. So they're not going to ask me anything about what substance was added, but they probably will ask me some why questions, like why was each of these things added. The only other bit of information here that I need is that 1.22 grams of benzoic acid was obtained. So that's 1.22 grams of benzoic acid, and that's going to be my actual yield. So if that's what was obtained, that's going to be my actual yield. Question 1. State and explain the color change in the flask during the initial heating. So they're not asking me to describe all of the color changes here, but we can go through that just for clarity. So my initial color is going to be purple, and this is due to the KMnO4. Or you could say due to the Mn7 plus ion. When that is heated, the initial reaction that's going to occur is going to be the reduction of the KMnO4 to MnO2. My M disappeared. And that's going to be a brown color. That's my Mn4 plus ion. So that's all they're asking for here is the color change, and we've explained what substance is responsible for the color. However, if they had asked for the overall color changes, we would need to add in that at the end the solution is colorless due to the complete reduction of the manganese ion to Mn2 plus. Question 2, this relates back to chapter 22 when we were learning about aldehydes, and one thing that was just specified in the mark scheme that you needed to know is that the active compound, the organic compound in almonds, is benzaldehyde. Part C, give 2 reasons why the solution was acidified with concentrated hydrochloric acid. So there's 2 reasons they want here. However, we kind of explained 3 reasons when we were going through this in class, so we list those out. The first and most important one is to convert the sodium benzoate, because remember, we don't make the carboxylic acid straight away, we make the salt. So to convert the sodium benzoate to our benzoic acid, our carboxylic acid. The second reason it's added is to neutralize any base that's left over. So any base that's remaining, because remember this is done under basic conditions, and we want to remove any of that strong base that's left, and the acid that we add can do that. The third and final reason is because the last step in our process, the reduction of the Mn4 plus ions to Mn2 plus ions, that reduction needs to be done under acidic conditions. So we were told in the question we're adding sodium sulfite, but that needs to be under acidic conditions. So adding the acid provides the correct environment for that to happen. Question D here is more straightforward than it might seem. How would you test the solution to find out if enough acid has been added? This is just testing the solution for an acidic pH, that it's under acidic conditions. So there's 3 different ways to do it. You can add blue litmus paper and it should turn red. Or use a pH meter and the pH should be less than 7. or you could use universal indicator, and again the pH should be less than 7. Question E, what was the purpose of adding the sodium sulfite solution? We briefly mentioned this before. It's added to reduce, so that's a key word, reduce the manganese 4 plus from MnO2 to the manganese 2 plus ion. This is insoluble in our solution, and it gives a brown color, a brown precipitate. The manganese 2 plus ion, however, is soluble and we get a colourless solution. Question F, why was the flask placed in ice before filtration? And that was to cool the solution to ensure that the maximum amount of benzoic acid was crystallized out of the solution, because the benzoic acid is less soluble in cold water. Part G, how would the crystals have been dried? They would be air dried overnight, or you could place them in a desiccator. So that's like the little oven we have in school that you can put at a temperature to heat it up to evaporate off any solvent that might be remaining. Then we're into a stoichiometry question here. So I have my equation from the first part of the question just copied in here. And I'm also given the density of the phenyl methanol. So I know that density is equal to mass over volume. So I can convert that then so that I can work out my mass of the phenyl methanol. By doing density multiplied by volume. So my mass is 1.8 times 1.04, which gives me 1.872 grams. So that's my first step. My next step is going to be converting that to moles. So number of moles is mass in grams divided by mR. My mass is 1.872, and separately I've worked out that the relative molecular mass of phenyl methanol is 108. Now you need to show your calculation of that just in case you make a mistake, because we want to get the maximum number of marks here as possible. So that's my number of moles of my phenyl methanol. The next step I can do then is my mole ratio to find out the number of moles of benzoic acid formed. And as we can see, the ratio is 3:3, which is 1:1. So therefore I have 0.0173 moles of benzoic acid as well. So how many grams is that? So I need to use my equation once again for mass. So it's going to be number of moles times mR, which is the 0.0173 moles, multiplied by the mR, which I've worked out separately as 122. You need to make sure that you show your calculation for that again. And that's giving me 2.115 grams. And that, ladies and gentlemen, is my theoretical yield. And that is what the question asked me for. So that's my final answer. Part 2 asks me to calculate the percentage yield. So my percentage yield is going to be my actual over my theoretical multiplied by 100. So that's going to be 1.22, which they gave me in the question for my actual yield. My theoretical yield that I worked out is 2.115, and when I multiply that by 100, I get 57.7% as my percentage yield.